Hello YouTube, welcome back to the channel. So in today's tutorial we're going to go ahead and learn how to build a simple convolutional neural network using deep learning. You're going to be using Keras and Tensorflow for this project. So if you're new to the channel, please kindly consider subscribing, liking this video and sharing this content with anyone. So let's get started with it. So the first thing you need to have Tensorflow already installed. In my case I'm using Tensorflow GPU version, so feel free to use Tensorflow the CPU version, it won't affect it. So I'm just going to go ahead and simply open up my Jupyter notebook here. So I'm going to open Jupyter notebook and then get started. So Jupyter notebook and then press enter, and that should open up Jupyter notebook on my local machine. So I've created an empty repository directory here. So inside of this directory I'm going to go ahead and create a new notebook. So I'm just going to click and create an Python notebook. So this is what we have. So great. So before I begin, I want to quickly mention that I already have also the written version of this article already written, and I assume that you guys have a bit of knowledge about neural networks and convolutional neural network. If you don't, I have another article written on introduction to neural networks. I think I have it written, so I'm going to keep the link in the description so that you guys can get access to it and you can see all the information about that specific article. So if I go into my stories and then I go to introduction convolutional neural networks, I have this article already written. So I'm also going to share this article with you. It defines everything that you need to know: what is padding, what is striding, what is let me just scroll out, let me see what we have here. Calculating, doing different calculations, talking about multi-channel images and different concepts about how convolutional neural networks work. Talk about max pooling and all that information, average pooling and everything else that you need to know to begin with, to get started with convolutional neural networks. So I have this article already written. If you guys want me to make a video about it, let me know in the comment section below. I'll do my best to make a video about it. But for now, we're going to go ahead and simply build a simple neural network. So if you want a quick guide on introduction to convolutional neural network, I'm going to link this article in the description so that you guys can have access to this article. But for now, we're just going to learn how to build a simple neural network, and that's all we're going to do. So great, assuming that you have the basic knowledge of how neural networks work, and we can get started with it. If in case you want to read more, I'm going to leave the link in the description. Okay, so the first thing we need to do, make sure that you created an empty Jupyter notebook, and which is loaded right here. So let me just talk about the dataset before we continue. We're going to be using the CIFAR10 dataset. So CIFAR10 dataset is just a dataset consisting of 32 by 32 dimensional pixel images of 60,000 different images of 10 different classes: the airplane class, the automobile, birds, cats, deer, dog, frog, horse, sheep and truck. So I'm going to be using this information to simply build a neural network that can classify images into one of these 10 different classes. So there are 60,000 images, so you're going to be using there are 50,000 for training. We're going to be using 10,000 images for testing, and you can read more about this information. I'm going to leave the link to this documentation inside the description. Okay, so let's go ahead. The first thing I'm going to do is to import all the necessary libraries that we use. Okay, so if you want to I made this cell a markdown, so I'm just going to make it a markdown. Just select it and press M on your keyboard to make this cell a markdown. So by default it is code, so if you go here it is code by default, but you can just press on the side here and just simply hit the M button on your keyboard, or come down here and change it to markdown, and then from there you can simply write in a markdown. So I'm just going to say convolution neural network. Okay, neural network, just like that. So just once we have that, I can just press shift and enter on my keyboard to run it, and then that to run, or you can simply click on this side just to run it. Okay, so once we have that done, I'm going to go ahead and import all the libraries that I need. So I'm going to make this a markdown cell, and just keep here let's just say import necessary libraries. Okay, so we're going to be using Keras and Tensorflow. So let's go ahead and actually import those two libraries. So I'm going to say from Tensorflow from Tensorflow.Keras, I'm going to go ahead and import the following. So I'm going to import sequential. I'm going to go ahead and import sequential. I'm going to import data sets, just like that. I'm going to go ahead and also import from Tensorflow. Okay, I got the spelling here right. So this is tensor. So from Tensorflow Keras dot layers, I'm going to go ahead and import the following. So I'm going to import a dense layer. I'm going to show where we're going to use a dense layer. We're going to import a flatten layer. You're going to import a conv 2D layer. underscore conv2d. So let me just get that right, conv2d, just like that. And I'm also going to be importing a max pooling layer. Okay, and all these concepts I have them explained. If you don't know what all this means, I have them explained on Introduction to Convolutional Network. All of them are explained inside of this article. I'm going to leave the link to this article inside of the description. Okay, so I'm also going to go ahead and import NumPy. So I'm going to import NumPy as MP. I'm also going to go ahead and say from Matplotlib, Matplotlib, I'm going to import pyplot as a PLT. And I'm also going to go ahead and import OS. The reason I'm importing OS is because I need OS to specify for my graphics card since I'm using a GPU. So this is really NumPy. Let me get that spelling right. So sorry for that. NumPy, just like that. Okay, so once I have these libraries imported, as I said, I was talking about the reason why I'm using the OS library. So the reason I'm using the OS library is because I'm using a GPU. So I need to be able to specify which GPU I'm using or which GPU to use and stuff like that. So if you're not using GPU, then feel free to skip that step. So I'm simply going to go ahead and simply paste the code for my GPU here, and I'm going to simply run that. So this is going to allow me to use my GPU because I'm using a Tensorflow GPU version. If you're not using a GPU version, then feel free to skip the code in cell 3. Okay, and one thing before we continue, let me just go ahead and safely save this. So I'm going to say convnet, so convnet, and then the dataset is the CIFAR dataset, so CIFAR_10 dataset. You can name this thing anything you want, but I'm just going to name my Jupyter notebook like that. Okay, so once I have those done, I have imported the libraries and I have specified which GPU version to use. Now let me go actually load my dataset. So let me just make this a markdown cell and just going to put in here load, and this is going to be load data sets. Just like that, load data set. So once I have this here, I'm going to go ahead and simply, let me just make sure I'm using 3. Okay, so 3 and also here 3. So let me just go ahead and simply load my data set. So this is going to return to me the following. So I'm going to say x underscore train. I'm going to say x underscore train, y underscore train, just like that. And I'm going to put another tuple here, and this is going to be x underscore test, right? Going to be test set, and it's going to be y underscore test, just like this. And this is going to be equals to the following. So it's going to be equals to you're going to say that data sets, we imported data sets from here. So it's going to say data sets dot CIFAR10, and then CIFAR10 dot load data, so load underscore data. So this is going to go ahead and simply load that data into our x train, and then our y x train, and then x train, y train, x test, and y test samples. Okay, so once we have this done, you can actually check out the shapes. You can do x underscore train dot shape. So if you do dot shape here, you can see the shape value you have. So you're going to use 50,000 for training. So if you go back to your documentation, it is mentioned right there, you're going to use 50,000 for training right there. Okay, so you're going to use 50,000 for training, and you're going to be using the rest 10,000 for testing. So you can see we have 50,000, which is the number of images we have, and then this 32 by 32 specify the dimensions of the image. And if you go back to your documentation, it specified it's a 32 by 32 pixel image. Okay, so these are the dimensions of the image, and we have this tree right here. So this tree says that talks about the dimensions of that image, so meaning the different color channels that the image has. In this case, image has 3 different color channels, the RGB color channel. And if you want to read more about the color channels, again, it's all in this documentation that I have. The link to this is going to be found inside of the link in the description below. Okay, so once I have that done, we can simply go ahead to actually check the x underscore test dot shape, and then you see what you have. So you have 10,000, 33 by 32 by 32 pixel image, and then it's of 3 dimension, the RGB channel, the red, the green, and then the blue channels. Okay, so that's what the 3 stands for there. So once we have this done, let's go ahead and actually reshape our data. So I'm just going to keep a markdown here, and let's just say reshapes data. So reshape, and we're going to go ahead and totally reshape our data. So to reshape our data, I'm simply going to say y train, and the y train is going to be equals to the following. So the y train is going to be equals to y underscore train dot resize dot reshape, and I'm going to simply pass in -1 and then a comma right here. Okay, so once we have that, then you can simply go ahead and simply print this out. And okay, I got an error. So y train, okay, I got the spelling of train wrong here. So this is train, just like that. So okay, and run that again, and then simply run this. So like this simply reshape our Y train data into a one-dimensional array, just a single dimensional array here. So this Y train consists of a different classes that of the images. So the big class 1, class 2, class 3 until class 9, also class 0, because if you go back to your documentation, we have all that information specified right here, and each of those classes belong to a given name right here. So now I need to actually specify those classes names. So what I'm simply going to go ahead and do here is simply go ahead and type it out. So I'm going to say y underscore classes, and you're going to use this just in a second. So y class is going to be equals to an array, and it consists of the following. So there's going to be airplane, airplane, just like this, airplane, let me just get that right, airplane, and then we have the automobile, so, and then we have the birds, and then we have the cat, okay, and then we have the deer. You can just look up this on the Visual documentation. I wrote it somewhere, so I'm just looking at it from that reference point. Okay, so we have dog, and then we have frog, just like this, and then we have frog, and frog, we have the horse. Okay, horse, just make that horse, and then we have the following, we have the sheep. Okay, sheep, just like that, a sheep. I think that's all we need, right? Sheep, and then also have the last one being a truck. Okay, so the last one is a truck, so here to say truck, so a string of truck, just like that. Okay, so once I have those classes specified, I can simply go ahead, make sure that your class names follow this exact conventions from the official documentation. The ordering is the same. Okay, so make sure that the ordering is the same as the one you have right here. Okay, so hopefully I haven't missed any order. So I can definitely check the length. I can check the length of the y underscore classes, so classes, just like this, and then run that. I can see I have 10 different classes there. So great. So once we have that done, let's go actually observe the images. So let's actually just make this a markdown by simply pressing M on the keyboard, and make sure you select the cell until it's blue. When its outline is blue, just press M on the keyboard. Okay, so in here, just going to say observe dataset. So observe data set, just like that. So to observe the data set, I'm going to create a function. I'm going to call this function show image, just like that, and this is going to take in an x, a y, and an index. Okay, an x, y, and then an index. So what I'm going to do in here, we're going to simply create a plt.figure, a matplot figure, and we're going to specify the figure size. So the figure size is going to be equals to a tuple, and we're going to say it's going to be 15 by 2 image size figure, and we're going to say plt dot im show, just to show an image, and you're going to say x, and then you're going to pass in the index. Okay, the index that we want to show. This will all make clear once we are done typing out this function, and then I'm going to say plt dot let's say x label, and x label is going to be equals to the y classes, so y underscore classes, which is this value we define right here, y classes. So this simply use y classes here, and then y classes, and pass in that index we want to 10. So we're going to pass in y, and for y you're going to simply go ahead and pass in the index, because we want to get the class of it. So if you get the class of it, from there we're going to go ahead and get the name. So for example, if I specify a class of an index of 5, and that index of 5 happens to be in the class 9, inside of the y data set, so it's going to go that class, and it's going to return to us the value 9, which you're going to go and simply pick the track. Okay, so that's what you're going to do. So once I have this done, I'm simply going to run that function, and then I'm going to call the function show image, and I want to pass in my y, my x train, and then my y underscore train, and then I want to pass in a value of 5 right here. So if I run this, now you can see 5 is just this automobile, and you can see here automobile, and it got this value from this part of the code right here. So if I change this index, now we should get another image. So if I change this to be 7, and then simply run this, now we get a horse. If I change this to be 9 and run it, now we get the cat. Yeah, and you can see the names right here. Good. So now you can simply pass in any index, and then observe the image at that specific index, or the image that correlates to that specific index. So great. So once we have this done, I'm going to go ahead and normalize our data. So let's actually turn this cell into a markdown. So just click on the side of the cell and press M on your keyboard, and you're going to call this normalize. So we're going to say normalize, and you're going to normalize our data set, just like that. Okay, good. So once we have this done, I'm simply going to go ahead and say x underscore train. Okay, before I do this, actually let me just print the x train, and let's see what we get. So x train, and let's print the value at index 0, and let's run it. So this is how the image looks like. Okay, now you can see the image, we have different values. So images, these are just pixel values, and pixel values range from 0 to 255. Okay, now we are going to actually normalize this data so that our images, our values for the pixels can range from 0 to 1. Okay, so if the highest is going to be 255, then we have to divide that 255 by 1 by another 255 to get a value of 1, right? That will be the maximum. Okay, and any other values will exist in between. So this divided by 255, the number you get will be 0 point something something, right? So that's what we're going to try to do to normalize our data. This will make easier for our machine learning model to be able to learn the data. So we're going to say x train, and then x train is going to be equals to x underscore train, and then x train you're going to divide everything here by 255. Since you're using numpy, it's going to go ahead and do an element wise operation on this. Okay, so we say x test, and the x test is going to be equals to x underscore test, and then divide by 255, just like that. So I run this, and once I have this, I can simply go ahead and do x and then do train right here, and then simply let's actually look at element 0. Okay, so now you can see now it is scaled between 0 and 1. Okay, so yeah, that's basically it. And with normalization, our model can learn better. Okay, because it doesn't have to do big changes just to tweak it. It can just make little changes and they can affect something. Okay, so once we have that down, let's go ahead and build our model. Now we have our data normalized, we have looked at the data, we have observed the data, and we have done all that all that processes. Now let's go and actually simply build a simple convolutional neural network. So I'm going to go here and simply add as in here. So I'm going to say build model, just like that. So in build model, what you have to do is, first of all, you're going to create a sequential model. So I assume that you already have a basic knowledge of deep learning. If you don't, or don't have a basic knowledge of convolutional neural networks, again, take a look at this documentation. The link is going to be in the description. Okay, so we're going to create a sequential model. So sequential and sequential is something that we imported, so remember that. So sequential, and make sure you can just run that. So just ignore these warnings for now. Okay, so I'm going to go ahead. You can actually go ahead and actually write a code above to ignore all these warnings, but for now let's just leave that there. We'll come back to it later on. So for the model that you have built, a sequential model, I want to first add a layer. So it's going to be a convolutional array. So I'm going to say convnet conv2d, and you're going to pass in a couple of things. The first you're going to pass in is a filter, and the filter is going to be you're going to pass in the filter, and you're going to use a 32 filter. Okay, a filter of size 32 different filters. You're going to use kernel, and the kernel size you're going to specify the following. So the kernel size is going to be a 3 by 3 kernel. Okay, so if you don't know what the kernel is, just look at this or documentation. It explains what's the kernel and what is a filter. Okay, so once I have that specified, I'm going to say the activation, and the activation is going to be equals to the following. So the activation is going to be a relu, rectilinear unit function, and you're going to say the input underscore shape. So the input shape is going to be the shape of our input image. In this case, it's going to be a 32 by 32 pixel image, right? So if you go back and look at the documentation, it's said right here, but this is a 32 by 32 image. Okay, so we're going to say the input size is going to be a 32 by 32 image. Okay, so once we have that done, that's basically all we need for the first layer. So we're going to do, if you go back, we're going to simply go and say the ways of doing this is convolution, relu, pooling, convolution, activation, pooling. So convolution, we've done the convolution layer, we have added the activation layer. So now we're going to add a pooling layer. Okay, so this is going to be a model.add, and you're going to say this is going to be a max pooling, and max pooling to D. You're going to go ahead and specify the pool underscore size, and the pool size is going to be equals to a tuple, and it's going to be a 2 by 2. Okay, we're going to have a pool size of 2 by 2, and if you're not max pooling it, again, this article explain what max pooling is. So if I go here, you can explain what max pooling is and what max pooling does. Basically we are going to divide, going to specify the pool size to be a 2 by 2, so it's going to be something exactly like this. So it's going to go to the image, and then for each of those 2 by 2 size is going to pick the maximum value. So here the maximum is 8, here the maximum is 6, here maximum is 9, the maximum is 9 also. So it's going to provide an image like this by using max pooling. So this helps to reduce the final computation that our model, our dense layers have to do. Okay, so I'm going to go ahead and actually add to another more layer, and this is going to be model.add, and this is going to be another conv layer. So conv2d, and we say find the filter, and the filter is going to be a 32. We're going to use let's say 64. These are just the numbers you can specify, 64, and then you can specify the kernel underscore size, and the kernel size is going to be a tuple. Okay, so let me just delete this and keep a tuple here, and this is going to be a 4 by 4 tuple, and you're going to also go ahead and specify the activation. So activation, and you're going to use here we're going to simply use a ReLU again, a rectilinear unit for the activation. And yeah, here we don't need to specify the input size, because the model, the output from here will be calculated, and then that will be the input size of this. Okay, so we're going to say model.add, and then you're going to go ahead and say a max pooling there. So convolution ReLU, which is the activation, and then simply pooling. So max pooling, and you're going to go ahead and specify the pool size, and the pool size just say get it right, pool size, and the pool size is going to be a tuple. You're going to use a 2x2 pooling size. Okay, again 2x2. So once we have that as a layer convolution activation and max pooling layer added, now I'm going to go ahead and simply flatten our output in order to pass it to the dense layers. Okay, so I'm going to say add, and you're going to say flatten, and flatten, you're going to pass in just a flatten layer, and flatten is something that we imported when you're importing the libraries at the beginning, so we can check that out. So I'm going to say model.add, and I'm going to add now the dense layer. So I'm going to say dense, and the dense, I'm going to simply call this, and you're going to pass in the units, how many units we want, and I'm going to simply go ahead and say 34. I want 34. And then the activation for this unit, I'm going to say activation, and the activation is going to be a ReLU, again linear unit. So model, I'm going to add another dense layer, model.add, and this is going to be dense, and then units, and the units is going to be we're going to add 10 units. And the reason why I'm adding 10 units here is very important, because we have 10 different classes, so each of those units can specify and give an output, right? So each of these units of those neurons can give a given output. So we're going to select the neuron that gives the biggest output. Since we have 10 different classes, then we need 10 different outputs and 10 different predictions, and then from all those prediction values we're going to go and select the maximum, the ones that give us the biggest prediction. So once we have that, I'm going to go here and specify the activation. So activation, and the activation, I'm going to use a soft max activation right here. Okay, good. So I'm going to go ahead and simply run this again. So we have an error. So it says that require run positional argument filters. Okay, so it's filters and not filter. So it's filters, and also here let me go ahead and specify filters and then run that. So we have got another error. It says that let me just go here, ReLU. Input of layer 2D is incompatible with the layer expected mean dimension for mean dimension to be 32 by 32. So let me just look at this. Yeah, and the reason why we're getting this error is that our image is a 32 by 32 pixel image, but also of three dimensions, right, of the RGB dimension. So I have to also specify that there. So I get another error. It's going to be softmax. So I got the spelling here wrong. So sorry for all those errors. So this is going to be softmax. Okay. So hopefully we don't have any more errors. So once we have that done, I'm simply going to go ahead and simply compile our model. So the error was that we need to specify 3 here, because it's a 32 by 32 image, but of 3 different dimensions of the RGB dimension, because it's a colored image. And then also here make sure that it's softmax. Okay, so that's mostly our errors. So once we have that, let's go ahead and actually compile our model. So build a model. So now let's make this a markdown, and then just type here compile. So compile the model, compile model, just like that. So once I have this, then I'm going to run this up. And so to compile the model, that's actually very simple. All you have to do is model dot compile, and then you just compile. So just model dot compile, and you just call this method. So in this method, it takes in a couple of arguments. The first you're going to pass in is optimizer. So optimizer, and you can specify the optimizer to be the Adam optimizer. Okay, I'm not going to explain why I use the Adam optimizer, because this is not a course about talking about different optimizers, and that might take us a lot of time. So for the loss, I'm going to specify it as pass underscore categorical underscore cross entropy, just like that. So categorical cross entropy. So that's the loss function that you're going to be using. And for the matrix, I just want the matrix to be matrix, and the matrix is going to be a list, and you're going to say the accuracy. So we want the accuracy to be there. So we want the accuracy to be there. We want the model to have the matrix to use to measure the performance of the model should be the accuracy of that model. So once we have that, I actually got the spelling of sparse. So categorical, I also got this wrong, so sorry for that typo. So categorical sparse categorical cross entropy, that's what I wanted to say. So great. So once I have that specified right there, I can simply go ahead now. Let's go ahead and simply train our model. So I'm just going to make this a markdown, and then just simply say train model. So I'm going to say train model just like this. So to train the model, we're going to go ahead and to train the model, and you're going to move into model.fit. Okay, so in here I'm going to pass in the x train, the y train, and then I'm going to simply say the validation. You're going to specify the validation data, so validation underscore data, and the validation data is going to be a tuple. You're going to pass in x underscore train, and then y underscore x underscore test, rather test, and then y underscore test. Okay, and then you're going to pass in the number of epochs that you want. So in this case, I'm just going to use epochs to be 5. Yeah, so feel free to use any number for the epochs, but make sure that it's not too big. So 5, 7, 6 is okay. So I'm going to be using 5 for this. So we have specified our x train, our y train, our validation data, and our validation is the x train and the y train in a tuple, and then I'm going to pass epochs to be 5. Okay, so I'm going to use go to 5 epochs to train our data, to train our model. So I'm going to simply run this, and this is going to go ahead and simply train our model. So I got an error here. It says that let's read the error what we get. Let me scroll down here and let's see what we are getting this error for. So if I scroll down here, let's see error unknown loss function sparse. Okay, I think I got the spelling of sparse categorical cross entropy wrong. So let me just get the spelling right. So it is sparse, so sparse this way, and then you're going to say underscore categorical underscore cross entropy. So I don't know why we got that wrong there. Yeah, it looks like I didn't run the cell again after updating that. So let's run it again. Now you can see everything is working. So let's give it some time. It depends on whether you're using a GPU or a CPU. It takes some time to train. And if you're having a computer that you can control the performance, so make sure that it's in performance mode just to speed this process up. So if you're having the fan kicking off, that is just my PC, the fan kicking into action. Okay, so this will take some time depending on your computer. So let's give it some time to train this model. Yeah guys, as you can see, our model is done training, and you can see we have a validation accuracy of 66% accuracy. We have a validation loss of 0.79. we have a accuracy for the accuracy of the model to be 70% and validation accuracy to be 66%. So great. Our model is not doing quite bad. If you want to train it more, that might increase the accuracy. As you can see, the accuracy increases as we go down the epoch. So you can increase these epochs, but don't keep it to be a ridiculous number, because there's something called overfitting. Your model might overfit. Okay, so great. So just keep it around 8 and below epochs, and that will be fine. Okay, so once we have that, let's actually go ahead and try. Let's see if our model has learned anything by trying to make some predictions. So I'm going to simply pass in m here, and then simply just say make prediction. So make predictions, just like that. So once I have this, I'm going to go ahead and say y underscore predictions, and then the y predictions is going to be the model model.predict, and then you're going to pass in the x underscore test. That's right here. So you're going to pass in the x test to get the predictions, and I'm simply going to go ahead and simply run this. So once I have this done, I want to go ahead and see the predictions of level 9. So I'm going to say y underscore predictions, and then let's try to get 9 and see. So the prediction is in this matrix. So for prediction for the level 9, for the index 9, which is the image at index 9, we have these predictions. Okay, so this might be a bit confusing, right? So we have 1 2 3 4 5 6 7 8 9 10. So we have 10 different values. So because on the last layer of the last dense layer of our network, we have 10 units. There are 10 different neurons, which is specified here. So each neuron is giving us a prediction, and these are the predictions of each neuron. Okay, so now we are going to go ahead and select the neuron that gives us the maximum prediction, and that will be the class to which the image belongs to. So to do this, I'm simply going to go ahead and do this. So I'm going to say y underscore predictions. I'm going to do this for all the predictions. We're going to simply pass in we're going to list comprehensions. I'm going to mp numpy.argmax. So make sure that you have numpy imported. So numpy.argmax, and then in here, going to go ahead and pass in our array, and you're going to say for array in y underscore predictions. predictions. So for each of the values where we have, you're going to get this array or list in Python. You're going to apply this list to numpy.argmax, which is going to return to us the maximum value of that specific list. And then you can simply go ahead and simply print the y predictions, and let's see what we get. So we have the predictions right here. Now, instead of having these numbers right here, now we can have an actual integer which corresponds to the class to which an image belongs. So great. So now that you're able to get those predictions, I want us to simply go ahead and simply make sure that the prediction that you are getting is actually a correct prediction. So what I'm simply going to do, I'm going to say y_test, and this is going to be equals to y_test, and then I'm going to simply do a reshape of this. So I'm going to say reshape and then pass in -1, so -1, and then a comma there. So that's all I want. So I'm going to reshape that data. So once I have that reshaped, I can simply go ahead and simply show image, and then pass in my x_test, my x test, my y_test, and then I'm going to simply pass in which image. So let's actually look at let's actually go ahead, and I'm going to simply call let's actually look at it at index 3. Let's see what predictions we get. So index 3, we got an airplane prediction. So let's actually check here. An airplane is for which class is an airplane. So let's let me just go up here and then create another cell above here. So what I want to do, I want to say y_predictions, and then simply pass in, let's say I want to get the predictions of 3, and let's see what we get. It's 0 and 0s. Let's if I look at our classes here, and 0, what does 0 stands for? 0 is airplane, exactly airplane. So if I go down here, and if you look at the prediction we got, is an airplane. So if I check index 4, and then let's say you got prediction of 6, let's see what 6 is, and then let's pass in also here 6 and run it. It says it's an automobile, and index 6 is not, I don't believe index 6 is not automobile, so that was a wrong prediction. Yeah, so that's basically it. That's how you can build a simple neural network. So you can see our model is good in some areas, and it's getting wrong the answers in some areas. So actually, let's go and look at let's see how we can look at model evaluation to evaluate the model on its performance. Okay, so to do this is actually very, very simple. You can do this using a confusion matrix, or you can do this using a classification report. So the first thing I want us to do, I want us to first go ahead and do this using a classification report, or you can also evaluate the model if you want. So you can actually just use model.evaluate and then simply evaluate the model that way. And to do that, it's actually very, very simple. What you have to do is simply call model.evaluate. So let's make this an M, and let me just type in here evaluate model, just like that. And simply what you're simply going to do, you're going to say model.evaluate, and simply go ahead and pass in the x_test, and then you're going to pass in y_test, and then simply run it. So it's going to return to us the evaluation of the model, and you can see we have an evaluation, the values right here. Okay, so great. So once we have this model evaluation, we got the accuracy of about 67%, and the loss to be around 0.936. Okay, so once we have that there, I'm simply going to go ahead and do the evaluation. So we can actually use these are the evaluation that we have, but you can also do this evaluation in a couple of other ways. The first one, you can use a classification report, and let's go ahead and use this. So you need to have sklearn import installed, or this will not work for you. So you need to put sklearn from sklearn dot matrix, just like this. From matrix, I'm going to go ahead and import classification underscore report, just like this, and then run that. So once I have this imported, I'm just going to go ahead and complete, and I'm going to say classification report, and in here I'm going to pass in the y_test, which is the truth value, and the predicted values, y predictions. Okay, just like that, and we got the classification report right here. So in predicting ones is as a predicting zeros as a precision of 69%, and all that predictions evaluations right there. Okay. Yeah, so I think the model is mostly weak when it comes to has a lower precision when it comes to predicting values of 2, and those are values of 2. I think that 2's let me just go here. So it'll be 1 0 1 0 1 2. So it's bad at predicting birds. Okay, so that's why it's mostly performing poor, having a lower precision at. Okay, so that's one we can evaluate this, and you can also, another we can do this by using a confusion matrix, and you can also evaluate this model using a confusion matrix. So to do this, I'm going to go ahead and say from sklearn dot matrix, like this. From dot matrix, I'm going to go ahead and import confusion underscore matrix, just like this, confusion matrix, and then run that. So once I have confusion matrix import, I'm going to say C equals confusion matrix, and in here I'm going to pass in the y, the x, the y, sorry, the y test, and then I'm going to say the y underscore predictions, and then that's returned to create for us a confusion matrix, and you can also view the confusion matrix this way. So now let's actually use Seaborn to visualize the confusion matrix. So I'm going to say from Seaborn, okay, this one will be import Seaborn actually. So import Seaborn, as SNS, just like that. I also need to import Matplotlib, which you already have imported. So I'm going to create a figure. So I'm going to say plt.figure, figure, just like this, figure, and I'm going to pass in the fig size, and the fig size is going to be a tuple, and it's going to have a tuple of 14 by 7. Okay. So once I have this, I'm going to say sns.heatmap, so heatmap, and I'm going to pass in my confusion matrix. I'm going to say and not equals to true, just to display the colors, sorry, the numbers. I can give it a plt.y label, and the y label are going to be just going to be the truth predictions, the truth values, and then the plt .x label, and the x label is going to be the predictions that we get. So predictions, just like that. Okay, and you're going to give it a title. So I'm going to say plt.title, and the title can be anything. Just going to say confusion matrix, just like that. And yeah, so once I have this, I can simply do a plt.show, and to show that confusion matrix. So this is the confusion matrix, and this is how it looks like. Yeah, so if you guys don't know how to read confusion matrices, again, I have a video explaining what confusion matrix is, and I'm going to leave the link in the description, so you guys can go ahead and learn how to read confusion matrix and how to interpret these values that we have here. Yeah, so that's how you can build a simple convolutional neural network using the CIFAR dataset, CIFAR10 dataset. So if you guys enjoyed this tutorial so far, make sure that you like this video, you comment, you leave a comment if you have any suggestions, subscribe the YouTube channel if you haven't. Guys, kindly consider subscribing, because only 10% of my viewers actually subscribe. So if you haven't said subscribe until this point, kindly consider subscribing, liking this video, and sharing this content with anyone who you think might find it helpful. Again, see you if you have any comments, let me know in the comment section below. I'll do my best to get back to you, and see you in the next one. Keep safe.